Hey everybody, today we're going to talk about, so let me get rid of this, finding the power of a product, and I'm going to explain this to you and how this works. So let me show you what kind of problem we're talking about, and this is slightly different. You notice I have product in all caps here. Well, I have that because it's different from finding the power of a power. All right, it's not the same thing, it's slightly different. So we're going to talk about what that looks like. And it's going to look sort of similar, but there's going to be some pretty big differences in it. So supposing I have this problem. Supposing I have 6x squared, and I'm raising that to the third power. Some of you might be saying, well, that looks a little bit like what we were doing before, except there is one difference here. And the difference is that instead of before, what we would have is we would just basically, you would see something like x squared to the third. Well, this is a little different because what we've got going on now is we've got a monomial that contains, it's a product this time. It's not just a variable or just a number. It's a variable and a number. So we have to look at how do we deal with this. So if we're going to deal with this, I think the first thing I always like to do is let's expand this, all right? And let's look at it the long way if we were going to do it. So if we were going to do this the long way, we would go 6x squared, and I know I'm raising this whole thing 3 times. So I'm just going to write it out 3 times, all right? Now, if I were writing this out 3 times, and I want to be picky, what I would do is I would group things differently. Is I would recognize that this is all one big product going on. You notice how I'm putting my dot product between everything. Well, I'm doing that to show you that now I can use the commutative property. All right, and the commutative property states that things can trade places when you multiply and it doesn't make a difference. So what I'm going to do is I'm going to take my 6's. I'm going to put all my 6's together, okay? And then I'm going to take my x squareds and I'm going to move those next to each other. And then I'm going to combine them and see what I get. Well, when I do my 6's, right, I'm going to get 6 to the third power. And then when I do my x's, I'm going to have times x, and then I know I can add 2 and 2, and that gives me 4, and then I add 2 and 2, that gives me 6. So I have x to the 6th power. So I have 6 to the third, x to the 6th power. And then the last thing I would want to do if I were going to make this entirely correct is expand out 6 to the third and figure out what it is. So 6 times 6 is 36. I'm going to evaluate it. Sorry, I was using very imprecise language there. And then 36 times 6 is 216. So my finished answer would be 216 x to the 6th power. Now, this is great that I did this, right? But the reality of the situation is that I don't want to have to do that if it's something that's really big or something that contains a lot of terms. So there must be a better way to do this, and guess what? There is. So the power of a product rule states that to find the power of a product, find the power of each factor and multiply each by the exponent on the outside of the grouping symbols. Okay, I wrote this out a little differently than it is in the book because I think in the book it just says multiply each factor by the exponent. Well, it's like by which exponents. So I want to make it very clear which ones you're multiplying it by. So what we're going to do is we're going to look back at that same exact example again. So I'm going to write this out one more time, and not the expanded way. I'm just going to write it out the simplified way. So we have this. All right, so what the rule says is that I'm going to look at each factor, right? So we're going to look at this first. And each factor always has an exponent. And if it's not listed, the exponent would be 1. And then what you do is you take each factor individually. So I've got this factor. I've got 2 factors in this one. I've got this factor and I've got this factor. Okay? So I've got 6 to the first, raising that to the third power, and I've got x squared and I'm raising that to the third power. So for my 6 to the first, I would write my factor or my base out, and then I'm going to multiply 1 times 3. So I'm doing what we did already when we took power of a power, but I'm doing it with the constant here. I'm doing it with the sixth. And so next, I'm going to do the same thing. Let's change colors here. I'm going to do it with my x. So I'm going to have x, and then I'm doing x to the 2 times 3. So now I've got two little things here I got to figure out. So my 6 is going to be the 1 times 3 gives me third. And then my x, the 2 times 3 gives me 6. And then I'm going to do what I did before, and I'm going to figure out that, well, 6 to the 6th power is 6 times 6 times 6, which is 216. And then I'm going to rewrite this in its finished form as 216 x to the 6th power, which, if I remember correctly, is what we found before. Except we did a lot more work before to get to that. So to do this, you see how much less writing there is on the page? That's the idea. It's to give you a quick and easy tool of how to find this. So that's going to be the end of this video. In the next video, we're going to do a couple more examples to show you this. This is usually one of the more confusing things for students to learn. So I appreciate you sticking by it.